let's say a person is standing here, and then she walks over to here. We could draw her two-dimensional displacement. She moved from here to there. But we could also talk about how far she traveled along each axis. We could imagine the y-axis and the x-axis. If we were to trace over, we see she only made it this far on the x-axis, and she only made it this far on the y-axis. We could draw a picture, in fact, and represent how far to the right she went by drawing an arrow, and we could represent how far up she went by drawing an upward arrow. So what are these two red arrows? They're not the path that she took. They are the parts of this displacement, or as we call them, they are the components. So as she travels along this angle, she has some x part to her motion, or x component, and she has a y part or component to her displacement as well. So we could say delta x and delta y are the components, the vector components of two-dimensional displacement. But what if instead it wasn't a person? Maybe it's a bird. And the bird is flying along some angle like this. And we know how fast that bird is traveling. The bird is traveling at 3 meters per second. Is that delta r? Well, wait, the units are meters per second, so no, this can't be delta r. This must be the bird's velocity. And because the bird is traveling on an angle, this is the two-dimensional velocity, meters per second. And we could talk also about how fast the bird is moving to the right, and how fast the bird is moving upward. So the x-axis component, or part, that's Vx. The y-axis component, or part, that's Vy. So just as we did before, we can make a statement. Vx and Vy are the components of a two-dimensional velocity. Any others we can do? Absolutely. Let's say that an object is sliding, maybe there's a block sliding down a ramp, where a person is pushing it down a ramp. There they are, pushing the block. And as a result, the block is accelerating this way. Like that. Well, we could talk about how quickly the block accelerates to the right. We could talk about how quickly the block accelerates down. And what do we see? Ax and Ay are the components to a two-dimensional acceleration. So components are, what are they? They're the legs of the right triangle. And they tell us, they describe the motion using the axes. Components are the legs of the right triangle. And components describe the motion along axes. Finally, they match the hypotenuse. What do I mean by that last one? If the hypotenuse is displacement, then the components are displacements. If the hypotenuse is a velocity, then the components are velocities. If the hypotenuse is acceleration, then the components are acceleration too. But if we were going to try and write down a definition of the component, a component is a vector that indicates how far and which way a two-dimensional vector extends along an axis. For example, if I asked you, how far does this 2D vector extend on the y-axis? You would say, oh, delta r extends this far. And then if I asked you which way does that delta r go on the axis, you would say, oh, it goes this way. And if I asked you how far does it extend delta r on the y-axis, you would say delta r goes this far along the y-axis. And if I followed it up by asking which way does it go on the y-axis, you'd say up. So these two vectors that we just drew are the components by the definition that we've just put down